Welcome to The Explainer. Today, we're diving into a hidden, almost invisible side of engineering, proactive ethics. Usually we're stuck studying the wreckage, right? Fallen bridges, massive recalls, tragic miscalculations. But today, we're flipping the script. We're looking at the disasters that never actually happened. The moments where professionals spotted a fatal flaw and completely changed course before a single life was lost. Okay, let's dive into this. Most case studies, they're total postmortems, retrospective disasters defined by fatal mistakes, cut corners, and the inevitable cover-ups. But our actual focus today is proactive ethics. This is what happens when someone spots a massive flaw, but instead of pointing fingers or just denying responsibility, they choose cooperation. They tackle the problem and they fix it up front. Section 1, the Citicorp Center Crisis. Think of this as a real-life structural thriller. So to see how proactive ethics actually plays out in the wild, let's head to 1970s Manhattan. High-stakes scenario here. Citicorp wanted this massive new headquarters, but there was a catch. A 1905 church sat right on one corner of the block. The solution? Build a 59-story tower sitting on just 4 massive 9-story columns. And get this, they placed them in the middle of each side, effectively cantilevering the entire building right over the church. Now notice that brilliant structural solution for the wind load, 48 chevron-shaped steel braces, which you can see in the diagram, forming the superstructure. But fast forward 4 years. A totally simple question from an engineering student gets the lead engineer, William Lemessier, thinking. Actually, scratch that. It forced him to completely recalculate the wind forces. He discovered the stress on those specific braces was actually 40% larger than originally calculated. And worse? He learned that strong welded joints were swapped out for weaker bolted joints during construction. His new calculations revealed a terrifying reality. A severe storm, the kind that statistically hits New York once every 16 years, could generate enough force to just tear those bolted joints apart and bring the entire skyscraper down. The fix? Welding heavy steel plates over 200 of those joints. And the price tag was a cool $8 million on a building that had originally cost $175 million to construct. Lemessier faced a monumental ethical choice. He went straight to Citicorp's executives, fully expecting his career to be absolutely ruined. But Walter Wriston, Citicorp's chair, actually supported him. They immediately coordinated with city inspectors, hired meteorologists to monitor the winds, and quietly prepped disaster relief agencies for a mass evacuation just in case. And miraculously, while welders worked secretly through the night for 2 whole months to secure the building, a citywide newspaper strike kept the press completely in the dark, totally averting mass panic. Lemessier did the right thing, and in the end, it actually enhanced his reputation. Moving on to Section 2, inventing safer automobile headlights, putting public safety first. Let's rewind the clock back to the 1930s. Now, we don't even think twice about flipping on our car headlights today, but back then, night driving was terrifying. Out of the 24 million vehicles in the U.S., there were over 31,000 fatalities, and a staggering 56% of those happened in the dark. Engineer Paul Goodell urged his peers to step up, pointing out that visibility was literally the weak link in traffic safety. The existing tech simply wasn't cutting it when it came to protecting human lives. The hardware itself was the core problem. Early headlights used these polished, silvered brass reflectors that tarnished incredibly fast. One study showed that light output dropped by 60% in cars that were only 6 months old. Plus, the unsealed bulbs couldn't handle the intense heat of a brighter filament without just cracking. So, General Electric engineers Val Roper and Daniel K. Wright stepped up to the plate. They used hard borosilicate glass to prevent that cracking and teamed up with Corning Glassworks to create a fully sealed, aluminized parabolic reflector. It was a massive technical leap, a brighter, vastly more durable, sealed beam headlight that wouldn't just degrade after a few months on the road. And this brilliantly illustrates an ethical triumph. When GE engineers demonstrated this innovative technology, the company had a massive potential monopoly right in the palm of their hands. They could have kept this revolutionary, life-saving tech strictly proprietary to completely crush their competitors. But they recognized the profound impact this would have on public safety. Instead of hoarding the patents, GE invited their own customers, competing headlamp manufacturers, along with Ford and General Motors, to a demonstration. They generously shared their sealed beam patents and actually allowed competitors to consult with GE engineers on the design. They chose universal public safety over total market dominance. Incredible, right? Section 3, Beyond Minimum Safety Standards, the Crash Test Dilemma. Fast forward to modern automobile safety, where the question isn't so much about inventing new tech, but exceeding minimum baselines. In the US, the NHTSA test cars by crashing them headlong into a rigid barrier at 35 miles per hour. That sets the government standard, but the IIHS, which is funded by insurance companies who obviously want to minimize crash damage, uses a totally different method. They use an offset frontal crash test into a partially deforming barrier. Why? Because real-world head-on collisions are almost never perfectly centered, they're usually offset. And here is the terrifying part. Some cars that earn the absolute highest safety rating in the government's full frontal test fail miserably in the independent offset crash test. I mean, just look at the violent deformation in an offset crash test. It's brutal, and it forces us to ask a really tough question. When an engineer working for a car manufacturer knows that their car legally passes the government standard, but they also see this independent data showing the car fails catastrophically in a real-world offset scenario, what is their ethical duty? Are they just required to meet the letter of the law, or do they have a moral obligation to go beyond minimum standards to actually protect the driver? Which brings us to Section 4, Overcoming Impediments to Ethics, Choosing to Act. It's a heavy dilemma, isn't it? So why do smart, incredibly well-intentioned professionals sometimes just fail to step up? In a lot of cases, the correct course of action is actually already known. The math is right there. Yet, people hesitate. 3 common psychological excuses tend to pop up. 1, it's not my problem. 2, if I don't do it, someone else will. And 3, I can't foresee everything. These excuses are basically shields. They allow us to emotionally distance ourselves from the real-world consequences of our work. It is so tempting to just throw your hands up and go, hey, if it's not my fault, it's not my problem. It instantly relieves you of the burden. But is it actually true? Absolutely not. Unethical decisions cost everyone. If an unsafe design causes an accident, the massive costs of lawsuits and redesigns, yeah, those are passed right on to the consumers. If a product causes injuries, every single one of us pays for it through increased health insurance premiums. Cheating on government contracts, taxpayers foot the bill. Unethical conduct, whether directly or indirectly, is always your problem because it costs everyone. So the crucial point is addressing that second excuse. If I don't do it, someone else will. Look, it's totally true that in tech and engineering, a lot of people are working on the exact same ideas. There's an immense rush to be the first to market. The thrill of beating the competition is intoxicating, and it can completely cloud your ability to look objectively at the safety of what you're actually building. But you have to step back and ask yourself, do you really want to be the first to gain notoriety for something that causes harm? Being first doesn't matter at all if what you've built is fundamentally unsafe. And regarding that final excuse, I can't foresee everything, well, okay, fair. Nobody has a crystal ball. You cannot predict every single bizarre way a user will misuse your design. However, engineering is an inherently creative process. Part of that creativity absolutely must involve explicitly looking at potential misuses. You do this by making foresight a core part of the initial design phase. You try to design around those potential problems from day one. You work with regulators early on. Ethics cannot just be some checklist you rush through at the very end. It has to be built right into the foundation. Which brings us to our final thought for today. We've seen a structural engineer risk his entire career in the dead of night, and corporate inventors happily give away revolutionary patents just to save lives. These are the real triumphs of proactive ethics. So the next time you face a difficult professional dilemma where the math is perfectly clear but the choice is incredibly hard, what are you going to do? Will you rely on an excuse, or will you have the courage to be the one who stops a disaster before it even starts? Thanks for joining us on The Explainer.